This video is a follow-on video to the video that James has done of his brother's heat pump system, and based on the experiences of Hugh and his system and everything that he actually managed to achieve with that system, it gave me the confidence to move ahead with my heat pump installation as well.
And we're going to go and have a look, and you can take us through it.
I will.
Thank you.
This is the monoblock heat pump. This is the bit that sits outside. This is the bit that collects the heat from the air and transfers the heat energy into the water that is then piped through the pipes, goes underneath the tap of the conduit into the loft space, and then you've got the electrical feed coming from the consumer unit in the garage. Again, comes through the house, comes through there underneath and feeds the power to the heat pump. Primary motivation, energy efficiency, to actually get rid of gas, but of course there's also the motivation to save some money, because most of these improvements that we've made over the years have actually saved us considerable amounts of money. I have been a person not at the bleeding edge, but certainly at the leading edge of adoption of these new technologies.
All
the
especially
way
with
through.
your solar.
With the solar, the
And your
solar
cars.
thermal, the cars, the battery, and my, all the other bits and pieces that I do. Because I'm kind of excited by it. That's the kind of person I am. I like all this stuff. So the heat pump was kind of the next step in that evolution, and getting rid of the gas supply completely. But unfortunately I do have microbore piping for the radiators. There was quite a lot of information out there that was a very difficult thing to do. Thought we were facing having to rip all the piping out and change everything. Hugh's installation really demonstrated to me that that wasn't necessarily the case, and you could actually run a heat pump over the microbore piping.
Did you get quotes of people telling you that you needed to
I did.
remove your
Yes, I did. Yeah.
all your piping and everything else?
Yeah.
Okay.
Some people basically just said rip it all out and start all over again. I got 5 quotes, and 2 of the companies actually said you had to rip it all out. A bit later on I'll talk a little bit about some of the early savings that we've actually seen with the heat pump just from 1 month's installation. Together with the optimizations that I'm doing, which I'll talk about, it's taken a while. We're now running steady state and actually seeing really good performance.
And this is 6 weeks later.
Yeah. Yeah. And also I wanted to add a second battery to the installation, a second Powerwall, so that we could actually benefit the cheap off-peak tariffs.
That's a Tesla Powerwall.
That's the Tesla Powerwall.
And how much battery have you got now?
With the installation of the second battery, it's about 27, 28 kilowatt hours.
Oh,
Yeah, so it's quite a lot.
it is, yeah.
Yeah. First of all, you have to think about what energy your house actually needs, and that means what heat loss that you're actually getting from the house. A requirement to get the boiler upgrade scheme grant from the government is that you also have an energy performance certificate of C or better. In preparing for this, I actually looked at what the heat loss for the house was. I did that in 2 ways. One was to actually look at top level methodology called the heating degree days methodology, which gives you a rough sizing for the heat pump that you actually need, which actually turned out to be pretty accurate. From memory, all you have to do is put in your location, how much energy you used last year. The methodology, basically you work it through, it comes out to a simple formula and just tells you the size of the heat pump that you actually need. And I've actually got a 7 kilowatt heat pump, and I think it was 6.3 kilowatt. That was quite accurate. And then separately to that, I went through and detailed for every single room the size of the room, the volume of the room, the types of walls we've got. Provided this to the people that were giving me quotes, so they could actually work out the heat loss calculations as well.
Okay.
And then we were able to compare the results. This is when I'd focused down on actually just 2 suppliers.
Okay. After you narrowed it down.
Narrowed it down to just 2 suppliers.
Yeah.
You have to think about things like the location of the heat pump, where you're going to sit it outside. It's quite a big lump of, it's a metal box basically, with a big fan in it.
Yeah.
But you also have to feed the flow and return pipes to it, the hot water and the cold water return. In my particular house, I had a location which was ideal for it, but it was actually quite a long way from the hot water tank. So it got some quite long runs. Runs all the way along the length of the house to the cupboard where everything is installed, which is about 17 metres, something like that, away. And in fact, that drove this this buffer tank dilemma. I think Hugh had spoken a little bit about buffer tanks. I was kind of thinking in the same way that buffer tanks were not the right way to go.
So the question was whether I put a buffer tank in or not.
Yes,
Yeah.
yeah. So I'd actually specified no buffer tank based on what I knew at that time. And actually, they quoted for no buffer tank. When the company I chose came and did the pre-installation survey, they basically said that they were a little bit concerned about the length of the runs from the external heat pump through to the airing cupboard where we've got the hot water tank and the valves.
So when they said the length of runs, is this to do with the pump capacity?
I assume so, yes. Now, as it turned out, you know, it's actually turned out extremely well, and I've learnt a lot more about buffer tanks since. Hugh's system and my system are very similar, except I've got a buffer tank. So I think what we're planning to do is do more of a deep dive into a particular day with and without a buffer tank, and actually see how the systems are behaving.
Yeah, that'd be fascinating.
Really interesting to do, yeah.
Yeah.
In terms of system design, I've got 17 radiators in the house, and they're all really old, really beaten up, and
When were they put in then?
they're put in when the house was put in.
30 years ago.
No, the house is 40 years old, 45 years old.
Okay.
So we actually made the decision to actually change all the radiators. I think I mentioned the Microbore. You know, we've actually got a 10mm Microbore down to the radiators, but we do have a backbone of 22mm. 22 runs to the house, and then it has Microbores coming off manifolds on the...
And it was the 22 in the house before?
Yes.
Okay.
Yeah, that's always been there.
Okay.
Yeah.
But
He's
that's
also-
interesting because that was put in, when, 30 years ago?
No, this is when the house was built.
40 years ago.
45 years ago.
So in saying that, most houses, that shouldn't be uncommon to that technology 40 years ago.
Yeah.
Yeah.
I assume so. I'm
Yeah,
not that
yeah.
familiar with the history
no.
of the radiator
Yeah,
pipes.
interesting.
I think we've demonstrated it can actually work with this kind of setup, with a backbone of 22 and then 10mm down to the radiators themselves. When you have a heat pump, you also have to identify a number of radiators that you want to keep open, so there's no thermostatic control over them. So you can always guarantee a flow from the heat pump through the radiators. So we actually identified 6 radiators in what we call the core of the house, the rooms that we use all the time. You know, the kitchen, the hall, the utility, and the bathroom, and they're just on all the time, and they actually keep the core of the house, you know, nice and cozy. The rest of the radiators I actually have on thermostatic valves. I'm really pleased that it's actually working really nicely. So in terms of my installation experience, you know, from placing the order to the installers coming along, I think it was about 6 weeks, so it's pretty good. Yeah, over the course of 5 days, they managed to fit everything and turn everything on. Commissioning, when they turned the heat pump on, they just wound everything up just to make sure there was heat coming out of all the radiators, and it was heating the house, and that was quite nice because we got the house nice and cozy again. At that point, we then had to start turning the knobs back. I think this is one of the things that I hadn't appreciated quite how much optimization was going to be necessary. You know, we've got a thermometer in the hall. The system actually uses something called weather compensation, so it compares the internal temperature and the outside temperature, and actually determines what the flow of the hot water through your radiators is actually going to be. This is the manual that you actually get. I did choose the Valent heat pump.
Yeah.
So this is a heat curve example in the manual. for a target room temperature of 20 degrees. But what you're trying to do is reduce the heat curve, use the smallest heat curve, because the flow temperature will be lower. That means your heat pump will be operating more efficiently. So the process that you go through is to start high and then choose a different heat curve until the heat pump really can't supply enough heat into the house to maintain the target temperature that you're actually achieving.
At that lower temperature.
Yes.
Yeah, because as it comes around, it's dropping further and further.
Because the flow temperature is dropping.
Okay.
Yeah.
Thank you.
But essentially, we've got the tank in the back there. That's the hot water tank here.
Yeah.
And this is the buffer tank below.
Okay.
This is the heat meter.
Mm-hmm.
That's measuring the flow, and all of these cables here that you can see here. This is all the additional monitoring that I'm actually doing of the temperatures of the different points in the water cycle. This is the radiator pump. You can see you can actually have a direct readout of the pump.
So what's that, 15 or 16, 40? That's temperature and flow.
So that's 40 watts. So it's quite a low power pump.
Okay.
And that's the flow rate.
So you installed it, you then tweaked it.
I was just talking about additional monitoring that I actually do, because I like to understand how things work. I chose, and not many people do this, but I chose, like you, to actually put a heat flow meter into the system that actually measures directly the amount of energy flowing in the system. So the valence system itself gives a very coarse measure, but it's very difficult to see what's happening when the system is running. So I chose to have the Open Energy Monitor system. So the Open Energy Monitor system is a company that provides a number of different solutions for measuring energy. Heat pump monitoring is just one of the solutions they actually provide. And you can see in the top right here, there's a kind of typical graph that you can get out of it, showing at the top there the two lines, the flow and return temperatures. I'm colourblind, so I actually don't know them.
So those are temperatures of your radiators, flow in and flow back.
Yeah.
That's the
outside. External temperature, yeah.
And this is
that's the output, the energy output from the heat pump.
And then
below that is the electrical input to the heat pump. So the ratio of the electrical input to the heat output of the heat pump is called the coefficient of performance.
Yeah.
So here you can actually see, well, in this window here, I'm actually getting a coefficient of performance of 3.99. So that means for every 1 kilowatt of electrical energy that's going into the system, I'm actually getting just less than 4 kilowatts from the system across this whole day.
And what's this one?
So most people actually get to this point. I've gone a step further because I had a buffer tank and I wanted to understand more about how the buffer tank was actually working.
Okay, so this top is the Open Energy System monitoring system.
It is, yes.
And this is yours.
So I have added extra sensors, digital thermometers, and also I'm measuring the radiator circuit. I'm actually measuring when that pump running around that circuit is actually running, so I can actually, and I know what that pump is set up as in terms of its flow rate, so I can work out the energy that's passing around the radiator circuit.
Okay, so we almost need to look at this layout with the buffer tank.
Yeah.
Because what this is, if I'm right, this is the bit between the pump and the buffer tank.
Yeah.
And then this is from the buffer tank to the radiators.
Exactly.
Okay.
Yeah. So this is the diagram of how everything is connected up, which is provided by Valent. It's pretty complicated to look at. So what I've tried to do is distill it down into a more simple diagram. So this is the very simplified diagram showing the external heat pump with the hot water feed into the house and the cold water return. this is a 3-port valve which directs the hot water either into the hot water cylinder to heat the hot water and return, or it directs the hot water into the heating circuit, which I'll talk about. So in the first instance, if it's actually heating hot water, you get this circuit. Interestingly enough, and we'll dig into this in a bit more detail when I do the video with Hugh, but the 4-port buffer tank is actually only used as 3 ports. They actually don't connect the radiator return to the 4th port, which is here. They actually use a common cold port, cold return.
How can I do that?
And this is a little bit unusual,
isn't it? Because it's going into there, and it's got to come out of there to there.
Well, it'll be a net flow depending on the speed of this radiator pump.
Yeah.
It would determine which direction water's flowing in that leg of it. But they do it this way because you're trying to minimise the amount of mixing that actually happens in the buffer tank.
Okay, that's fascinating. I never realised that.
Yeah. So this is a particular thing that the installer does. I haven't seen it done anywhere else, but they think it's very effective, and it's proved to be very effective. But this.
So it's almost as if this is feeding all the way through then. And it's not quite, you've got a buffer tank and it can go this way, but and then this pump is using this as a reservoir to pump on to boost through the system. Yeah. And then the cool water's coming back, and it's only going there if there's a shortfall in flow to that pump. Yeah. Otherwise it's going straight back to the...
So one of the things that I've been investigating is what's the effect of the flow rate, that pump.
Yeah.
So if you have the flow rate the same as the flow rate here, then you probably are just getting a straightforward flow all the way around the system. But if you have that higher, then you've got more of a flow around here. So this is another one of those knobs on the system that I've been experimenting with. You know, what happens when you actually change the flow of that, because it's got a knob on the front of the pump that actually tells you what the flow rate is, so you can actually do some interesting experiments on that.
It's quite interesting because you were talking about measuring the outside temperature and how much heat you put in, and I presume that's dictating your heat pump.
Yeah.
But then you've got a circuit here where you've got flow here, and I suppose, what does it monitor? It doesn't monitor anything, or is it just...
It is, because what I have done, I've actually put temperature probes on these points here, so I'm actually measuring the flow and return in this circuit. So if you know the flow, you know what the heat flow is in this circuit, and that's what this diagram is actually showing you. This is the radiator circuit, so I've got the radiator feed and return, and I've actually got the radiator heat calculation. So you can see here that I assume with this particular one that the flow rates must have been very similar between the radiator pump and the heat pump. We're actually getting a lot that, the same energy is just flowing straight through in the steady state there through to the radiators from the heat pump.
You know something, I've learned a huge amount just by watching that. I never realised the flow system. I thought it went into the buffer tank and then out at the bottom. And the radiator went back in the pump. And as you said, if you've only got 3, you're not using this 4th one, you're not getting so much turbulence in here. This is basically just a top-up. So it is in fact just doing that. And this is just acting as a buffer to top up.
It's kind of almost like a volumizer.
Yeah, it is.
But it's not quite a volumizer.
Yeah, it is, yeah.
So it's not a traditional buffer tank in the sense.
It's not what I thought the buffer tank would be.
Yeah. So it's this, as I say, this seems to be the installer I used are the only company that suggested this. It was the only people I've come across that actually do it this way. And we're getting good performance, so it's obviously working.
It doesn't surprise me because I think you've basically got a normal heat pump going around, but you've got this extra pump in the system, and that's able to work because it's got a volume of water, And if there's any discrepancy in flow from there to there, this buffer is acting, and it either sucks or discharges on this thing there. No, absolutely.
Yeah.
And yeah, these your temperature probes is interesting as well. So you've got a temperature with the warm water coming in, and then this is it when it goes back out, and that's going onto your graph.
Yeah. This is the traditional heat flow,
Yeah.
heat flow meter measuring the flow and the two temperatures here, and that gives you the standard graph that.
And that's your open source energy.
That's the thing that gets. That's the graph that everybody gets. Gets to see. I don't think many people see this side of it.
No, they won't. That's why I said you're a rare beast. Because you're showing us something that we won't understand. Yeah, fascinating.
Let's see.
Wow, that's a revelation to me. I never.
Is it?
It is.
Oh, right.
I never, because I couldn't understand this. As I understood it, would discharge into here, and then this other one would come pump in here and suck out here. And I didn't realise these two were connected.
All right.
And in my head, you're going to get a huge amount of turbulence in there.
Yes. Yeah.
And a lot of mixing. And how is that going to be efficient?
Yeah.
But in fact, what's happening is this is actually running all the way through from your heat pump with a top up here.
Yeah.
So this can flow or top up or whatever
Yeah.
to make up a balance between the two pumps.
That's right.
And it is like a volumizer.
And what happens is if your heat pump actually turns off, this pump, which is controlled by the heat pump controller, tends to run on. So even though you're not getting any heat through from this loop here, this will continue to run and actually use the hot water reserves in here, and it will actually continue providing heat to the radiators until that's depleted. And one of the things I've just recently done is added a thermometer, digital thermometer, onto the buffer tank. I actually found, when I read the manual, it actually has a port to actually insert a digital thermometer. So I'm actually now collecting the temperature at this point here, and you can actually see the depletion, the temperature drop. The temperature here actually drops, starts off being close to the temperature at the top of the tank, or this temperature here, but as you run this for longer, it actually drops to the lower curve.
So as you run it without the heat pump thing.
Yeah.
Okay, so when you run that on its own and that's off.
Yeah. Yeah.
How big is the buffer tank?
45 litres, I think. So there's two things to talk about. One is, what kind of performance am I getting from the system? But based on the performance that I've seen so far, I'm actually getting over 4 on these particular days.
So that outside temperature is probably about 5.
Yeah.
And this one's about 10.
It's about 10, yeah. But I just throw this up really just to show that, I'm getting coefficients of performance of 4. I've actually had 5.8 out of the system, which just blew me away. I never expected it to be that high.
But what I find interesting looking at this is your heat pump's running continuously here.
Yeah.
And whereas here it's on and off, and that's 10 degrees and that's 5 degrees.
That's exactly why I chose those two graphs. Yeah. Smart, you picked up on that.
Good, showing I'm paying attention.
Yeah.
And when it's running it continuously here, you can vary the output of the heat pump down to 30%, isn't it? So it doesn't run at full. That's
right. So this is actually a 7 kilowatt heat pump.
Yeah.
So you can actually see that here it's running about 3, around about here. If that's 5, that's about 3. But it will also run up to, this is peaking at 10. But then I think one of the advantages of the valence system is you can actually modulate the output appropriately.
So it's running continuously here, which is good for efficiency.
Yeah.
At a lower output.
Yeah.
So it's not running maximum.
Exactly. Yeah.
So if this temperature was lower, you would see the output going up, but probably still running continuously because it just means it's modulating up to a higher output.
That's right. So on a colder day, that line would be higher.
Well, to me, that's nice to see that. If it was mine, because this on and off isn't ideal, but it's warm. So here when you're getting down to 5 degrees, which still isn't freezing, but it is, the pump's running continuously at a lower output, which is perfect.
Yeah.
Which, to me, if you oversize the heat pump to 12 kilowatts,
Yeah.
you'll probably see that there,
Yes, exactly.
because the pump is too big
Too big.
for the system.
Yeah.
While the household is quite happy that they've got heating, they don't understand how
Yeah.
inefficient, and especially in this day and age when electricity and everything else costs so much more, unless you put in cheaper, put in batteries and things like that.
Yeah. I'm really happy with the coefficient performance levels that I'm actually seeing. The other thing is, how much is it costing us, because we're just running off electricity. So I'm collecting a lot of data, but I've just literally before you arrived, I just went back to I had my energy bill for January, and I thought, I just wonder what my energy bill was last January. So I dug it out, and last January I paid £376 for my combined electricity and gas.
And with that, that's the whole of your house, your heating, and your car.
Yes. Yeah.
And this time, same again, whole of your house, heating, but this time all electric as opposed to
and there's
gas.
no gas.
Yeah.
And actually
And
it's
a heat
split
pump.
between these two periods, because this is when I switched to Intelligent Octopus. So I'm not getting the full benefit of Intelligent Octopus for the whole period, and I'm still running optimizations. So I was actually charged £166 this January. Of course, it depends what the heat outside temperature was doing. I think we've had a cold January, so I would imagine it would be similar or worse
It's
than
a
last year.
quick snapshot.
It is a quick snapshot.
And you're saving £200.
Exactly, in 1 month. Now that's a winter month. During the
That's
summer
significant.
you won't be benefiting quite as much.
Significant.
It is, yeah.
£200 more to spend on groceries or the pub or...
Yeah, I mean it's quick and dirty. Look, and
But it's good.
over time I'll be plotting the graph to see how much I am
it'll
saving.
be fascinating.
But if you, I think my takeaways of this is, if you actually install a heat pump that's carefully designed, carefully optimized, and carefully sized for your house, then you can realize some real savings, as well as stopping burning gas. It's a bit of a no-brainer to me, to be honest, and it gets me very frustrated that heat pumps have such a bad reputation, or there's a lot of fear, uncertainty, of doubt around them. And one of the reasons I'm doing this video is to try and help people make that decision for themselves. Everybody's got to decide whether they're going to go down this route or not. But hopefully, seeing the results of systems like mine, systems like Hugh has installed, will actually give them the confidence that you can actually go down the heat pump route and actually install heat pumps with systems that are Microbore based as well. Well, I learn from Hugh's installation, you see, so that's why I wanted him to go first.
I know. I'm going third, so I'm going to learn from both of you. Brilliant.
Yeah.
Thank you.
Yeah.
So you're going to